I am C. Ramesh, Assistant Professor at Department of Mathematics of Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this lecture series video, we are going to discuss about quantitative techniques from the topic. We deal sequencing problem, n jobs, two machines. Before that, what is sequencing problem? Consider the publisher performs. First one is printing and next is binding. Suppose he published some 10 books. The time required to printing and big and binding each book is known. He is a printing machines. He uses the printing machines and binding machines. Print first and then go to bind next. The problem of publisher is to decide the order in which the 10 jobs should be done so as to minimize the total time taken for all the jobs. Such problem is called sequencing problem. The sequencing problem is a problem of determining sequence order for a series of jobs to, to be done on a finite number of service facilities so as to minimize the total time taken for his finishing all the jobs. So what is total elapsed time? The time between starting the first job and completing the last one. So what is the ideal time? Ideal time on a machine is a machine ideal during the total elapsed time. So now take some example for this. The first problem, there are five jobs, each of which is to be processed through two machines, M1 and M2. Processing hours are as follows. First job, if it is on M1, machine 1, it takes 3 hours, and if it is on M2, 4 hours. Likewise, second job, third job, fourth job, fifth job, and the duration of machine 1 and machine 2 are given. So using this, we find the optimum for the five jobs and the minimum total elapsed time. And the second one is find also the idle time of machine M1 and M2. So how calculate this? First we write the sequencing order, which job take first. So write all the five jobs and its machine durations, everything is there. First in the machine one, along among machine one and the machine two, which time taken is very minimum. So in first one, 3, 4, 8, 10, 5, 6, 7, 5, and 4, 8. Among this, which one is minimum here? 3. In the first job, on machine M1, it takes only 3 hours than the other machine durations. Therefore, we take first job in first order. Therefore, the order of cancellation is 1. So we write it in the left side of this left side. And then we cancel this first job. Then which one is second job among these four? Among these 2, 3, 4, 5, which machine duration is the minimum? So again, take fifth job. Here is only 4 hours. Therefore, we take second order is job 5. So write in the left side. Then the remaining three, uh, 2, 3, 4 jobs, which time is minimum. So 8, 10, 5, 6, 7, 5. So here 5 is minimum, but it is on first machine and the second machine. Both are having the same time durations, but we consider the first machine. Therefore, we take in order in the third job to the third. Therefore, we write it is 3. And the remaining two machines to job to second job and the fourth job is there. But minimum time duration 8, 10 and 7, 5. Minimum duration is 5 hours. It is in the fourth. Therefore, we take fourth or uh, right to the right side. So fourth is to the right side. The remaining only one job. It is left. Therefore, 2. So time duration is on 8. Therefore, the minimum cancellation is 2. Therefore, we take order in this sequence order 1, 5, 3, 2, 4. So we assign the jobs in the sequence order that is called optimum sequence. Next, what is the processing time of M1 and M2? Then we find what is the total elapsed time, and in this time durations, what is the ideal time of machine 1 and machine. So the time duration for this work for this fourth job on machine 2 takes 5 hours. Let the machine is running in 31 hours. After that, we start the machine to work after 31 hours. So 31 plus 5, 36 hours. Among this, then all the jobs are completed in these two machines. So now we calculate what is the total elapsed time. Total elapsed time is what is the total working time between, from starting to end. Here we start the machine on 0 hours, then we complete all the jobs, and then we finished all the jobs up to 36 minutes. Therefore, the time duration is 36 hours. So the total minimum elapsed time is 36 hours. Now, what is the ideal time of machine 1? Ideal time is the machine rest between the total elapsed time. On machine 1, 0 to 3, 3 to 7, 7 to 12, 12 to 20, 20 to 30, 27, completely he running without stop. But after 27 hours, the machine 1 will start, the machine 1 stop. So it is the ideal time. So what is ideal time? The total elapsed time is 36, but the machine 1 stopped the work up to 27 hours. So 36 minus 27 is 9 hours. So in this 9 hours is ideal time of machine 1. So what is ideal time of machine 2? So, but initially, the first job is assigned on M2, but the M1 completed its work, then M2 will start. Up to that level, the M2 is ideal. Therefore, after 3 hours we start. Therefore, 3 hours is ideal time, and then it is continuously running. So 3, 7, 7, 15, 15, 21, 21, 31, 31, 26, continuously running. Therefore, 3 hours only it takes rest. Therefore, the ideal time of machine 2 is 3 hours. So it is our total elapsed time, machine 1 and machine 2. Okay, we consider the next problem. Here, some of the minimum, we find the minimum total elapsed time of the required to complete the following jobs on M1, M2 in order M1, M2. Find the total minimum elapsed time. The tasks are A, B, C, D, E, F, G, H, and the times are 2, 5, so on. So, what is optimum sequence? By the previous way, we calculate the optimum sequence A, C, I, B, H, F, D, G, I. Then we find the total elapsed time by this way. So we write the job order A, C, I, B, M, M, H, F, D, G, E, and the time, first we start the time 0, and the timeout for A is 2 hours. After the 2 hours, the machine 2 will start. So 2 plus, and the time duration is 6 hours. So 2 plus 2 is 8. Next, we start the second job after 2 hours. It takes a 4 hours duration. So 2 plus 4, 6. Then it take to machine 2, but machine 2 is still running here. Therefore, after 8 hours, it will start. So 8 plus 7 hours duration. So 8 plus 7, 15. Then we take the I job on machine 1. So machine 1 is running 6 hours. So after 6 hours, we start. So 6 plus, and the time duration is 4. Uh, so 10 hours duration. So after that 10 hours, we take this job to the machine 2, but already machine 2 is running. After 15 hours, we start the work. So 15 plus time duration is 11. So 26, so on. So using by this way, we calculate all the running time of machines. Now we find the total elapsed time. So we start the work in 0 hours and finish all the work up to 61 hours. Therefore, the total elapsed time is 61 time units. So what is the ideal time? But we consider the machine 1. Machine 1 start 0, 2, 2, 6, 6, 10, 10, 15, 15, 20, 20, 28, 28, 37, 37, 44, 44, 50. Continuously it's running, but after 50 hours, it will not working. So it was not working. Therefore, the machine 1 take idle. So what is the total elapsed time? 61. And the working time of machine 1 is up to 50 hours. Therefore, the idle time of machine 1 is 61 minus 50, 11. And similarly, we calculate the idle time of machine 2. So machine 2 start its work from 2 hours. Therefore, up to the 2 hours, the machine M2 is idle. Therefore, the idle time of machine 2 is 2 hours, and it's completely running. So without idle of between the duration, therefore only 2 hours is idle time of machine 2. So it is a optimum sequence and ideal time of machine 1.